Yesterday we talked about we talked about the one solution, no solution, infinitely many solutions. And we talked specifically about what that looks like on a graph. Today we're going to talk about what it looks like on a table as well. We're not going to talk about equations yet because we're going to do that. That's going to look completely different. We will learn about that when I get back next week. But we're going to start by looking at graphs and tables. So when we had a graph, these are the same equations that we used yesterday with Cutie Pie and her recording situation. Okay, so in the graph, when there was one solution, there were two lines that intersect at one point. I should have written that as TWO, but whatever. Okay, so there are two lines that intersect at one point. This point represents the solution to the equation. So in this case, my two lines cross. Where they cross is the solution to my equation. Okay. Now, when I had, and I can see that in my, if I look at my graph, if I put 2x minus 1 and x plus 5 into my calculator and I look at the graph, I can see, even though it kind of goes off the edge there, if I wanted to, I could zoom out a little bit. Let's make my y's a little bit taller. Let's make it 15. And let's look. I can see that I do have an intersection. And you can tell that these lines are going to intersect. Even if you look down here, you can see that they're getting closer. And right there is where that intersection is. It's not so easy to find, but it's doable. Actually, I think if we trace, we can trace all the way over there and kind of get an idea of where it is. Now, just FYI about trace. Left to right moves along the line, up and down moves between the line. Now, it's not going to be perfect because we're tracing, but it looks like it's about 11. See, at 11, both of these have around the same value. So I'm thinking my intersection is around 11. So let's look at the table. The table is going to give us that precise answer. Now, what we're looking for is, remember, we want both of these values. Whatever x I put in, I want to get the same y value out. Well, if I look right here at 6, 11, 11, this means when I put in an x into the first equation, I get 11. If I put an x to the second equation, I also get 11. So that's how I can tell what my solution is. My solution is the row here, 6, 11, 11. That row shows me my solution. My solution is an x, y coordinate, so it's going to be 6, 11. 6, 11 is the solution to this problem. So in this case, there is only one value for x that makes both sides of the equation have the same value. Okay? And there's lots of values of x here, but only this one right here is the only one that makes me have the same output. Okay? So that's what it looks like when we have one solution. Our graph is going to have two lines that cross at one point. Our table is going to have one row where y1 and y2 are the same, and my answer is x, comma, y. And in this case, that was 6, comma, 11. Okay? But again, I'm not looking at y, I'm looking at x, comma, y. Okay? And again, we're going to save equation for later. Now let's look at the other one. The next one had no solution. Okay? So I had y equals 3x, and I had y equals 3x plus 4. Okay? Now, when I look at the graph, I pretty obviously have parallel lines there. So I can see that I've got parallel lines. Okay, so when I'm looking at my graph, there are two parallel lines because no value of x produces the same y value for both sides of the equation. Okay, so we have two parallel lines. Now, in the table, if we look at the table, here's what that looks like. I have no rows where y1 and y2 are the same, but remember, I could just keep scrolling forever. It might take me, maybe my intersection is at negative 500. Maybe my intersection is at 36. I don't know. What I can see, though, is that 0 plus 4 is 4. 3 plus 4 is 7. 6 plus 4 is 10. 9 plus 4 is 13. Every one of these y1 and y2 values is the same distance apart. They're always 4 apart. That means they're never going to get any closer. That means I have no solution. So I have no x values, no values for x that make both the sides of the equation have the same value. And again, the way I can tell that, yes, I could scroll, but remember, who knows how far back or how far up or down I have to scroll to find the solution. What I can look at, though, is right here, it's easy. 0 plus 4 is 4. 3 plus 4 is 7. 6 plus 4 is 10. I see that they're the same distance apart. That means they're parallel. Okay? So, again, one solution, I have two lines. They cross at one place. The solution is the coordinate where they cross. There's only one value for x that makes both sides have the same value. For no solution, I have two parallel lines because no value of x produces the same y value. In the table, I have no values for x that make them the same. So I'm going to see every one of my values in my table are the same distance apart, just like parallel lines are the same distance apart. Okay. The last one I might see is infinitely many solutions. Okay. Now, with infinitely many solutions, when we saw infinitely many solutions, we ended up seeing one line. Because basically you ended up having two lines graphed on top of each other. So let's take a look at what that looked like. We had 4x plus 1 because it was $4 per song plus a $1 charge. And then they had $4 per song plus a $6 charge, but there was a $5 discount. So 4x plus 6 minus 5. Okay? Now, when I graph that, my first line graphs, and then my second line graphs right on top of it. You could kind of almost see it moving. And it's done because I don't have my little spinning thing in the corner. I'm done. I've graphed my two lines. They graphed right on top of each other. Okay? So there is only one line because every value of x produces the same y value. There's only one line because every value of x produces the same y value for both sides of the equation. Okay? So, again, what that looks like is it looks like the graph graphed right on top of the other one. Okay? Now, if I look at the table, what I'm going to notice is every single row has y1 and y2 equal. That means if I put in a 0 for x, I'm going to get the same y values for either one. If I put in a 7 for x, I'm going to get the same y values. If I put in a 700 for x, I'm going to get the same y values. Okay? So when I have infinitely many solutions, every single row in the table has the same y1 and y2 values. So there are infinitely many values for x that make both sides of the equation have the same value. Okay? So again, one solution means they cross in one place. In the table, we're going to see the same y1 and y2 values. For no solution, you're going to see parallel lines on your graph. And there's going to be no values that make the equations have the same value. And what you'll see in the table is that all of the rows have the y1 and y2 are the same distance apart. So maybe you add 4 or add 12 or subtract 3. They're all going to be the same, every single one of them. Infinitely many solutions, we have one line. It looks like only one line graphs because they're basically the same equation graphing on top of each other. There are infinitely many values for x. That means every row in the table is going to have the same y1 and y2 because it doesn't matter what you put in for x, you're going to get the same y value out of each of these equations. I want you to put these notes where they're safe. On Monday, I'm going to give you your new unit tab. So I don't want them to disappear until then. I don't want you to put them in because I want to make sure that we put the tab in first. So keep these safe. We will tape these in Monday. Have a good weekend, and I look forward to seeing you.